Okay, the last talk. I know that you are waiting for the glass of wine, but I just only take a few minutes. Good morning, everyone. My name is José Galván, and I am working on this project with my partner, Hugo. We are both students that currently are completing the master's program in artificial intelligence, pattern recognition, and digital imaging, at Universitat Politècnica de València. This project is supervised by Professor César Ferri and Carlos Montserrat, and the title of the project is Restoration of Photographs Damaged by Data Using Segmentation and Inpainting Techniques. This is a quick overview about the presentation of today. And let's begin with some context. The last October, a meteorological event called Dana, isolated depression at high levels, struck on the Valencian community, causing severe flooding and damage. It had a great impact, like more than 200 fatalities, 78 districts were impacted, and more than 800,000 residents were affected. There were many thousands of material losses, as you can see in these photographs. In this context, many photographs were damaged by mud and humidity, and Salvem Les Photos project was born. The objective of this project was to preserve and clean and restore the physical photographs, but UPV Bellas Artes School, led by Pedro Vicente, who is here, Pilar Soriano and Esther Nebot, took one step further with Recuperar las Memorias, or Recovering Memories project, with the objective of not only clean and preserve the photographs, but also apply a digital restoration. To date, more than 200,000 images are received. As you can see in these photographs, there are the volunteers that are working in the cleaning process, preservation, and also in the digitalization process of the photographs. Our role in this initiative is on the use of artificial intelligence. Brain joins Recuperar las Memorias project to help with the digital restoration through artificial intelligence. And we are working the development of a pipeline that reconstructs the damaged areas of the affected photographs using deep learning models. As you can see, our two main steps, our two main stages in our pipeline are damage segmentation and also the image restoration with inpainting techniques. We used two approaches to get the damage segmentation. The first one was with a unit neural network. First, we segment the people that are present in the photograph. So we think that it's very important to detect the person because if we place a damaged mask in this area, it could be a critical mistake. Then during training, we divide the image into three main regions. People region, a region with the actual damage, because if we're missing a damaged pixel, it could be considered as a false negative, and the clean area, or the clean regions, which if we predict damage here, it could be considered a false positive. We also assign a manual weight. As you can see, we name it as alpha in this diagram to penalize some errors. For example, the people region and also the false negatives has a more high alpha value, because we want to ensure that no real stain is left undetected, and we can avoid that false damage mask be detected in the face of a person. Our second approach to get the damage segmentation is combining YOLO plus SAM2. We found that SAM2 is very useful to detect a binary mask, but we needed to pass either of pixel coordinates or bounding box that frames the damage in the photograph. For this reason, we fine-tune a pre-trained YOLO model to detect the damage, the stains in the photograph, and then we passed these bounding boxes to SAM2 to get this kind of segmented binary mask. Once we have the segmented binary mask, we apply the post-processing step. In this case, we remove some small noise pixels and fills some small holes, and we applied a dilation over the mask contours. It was very useful because it works better with the subsequent in-painting process. In the restoration process, we used the damaged image, or the original one, and the dilated binary mask. With these two images, we ran the in-painting process with a stable diffusion in-painting model. And with a prompt like this one, photo restoration, realistic, same style, and clean stains. And we achieved the results like this one, where stains were removed and also the damaged area has been reconstructed. If we analyze the result, we can observe something interesting. For example, the street has been reconstructed coherently in perspective, but some flowers appears here. I didn't ask the in-painting model to add flowers in the scene, but it did. Also, there were some another hallucinations that we found when we tried with in-painting models. In this case, a stable diffusion in-painting model. For example, appearance of random people, as you can see. Here we got a little boy, and the clothes of the woman in the scene has changed. But there was a more stranger hallucination that we found. Are you ready? Here we got a bride. She is ready for the wedding. This kind of hallucination we solved by prompting techniques, adding some negative prompt, and adjusting some parameters in a stable diffusion model. But we faced with another problem. We need to preserve the identity of the people that is in the photographs. It's a critical detail. And we noticed that even there has no stains in the face of a person, a stable diffusion, in this case the painting model, affects the face. There has two main hallucinations. The first is the letters that the model put here, but there is a more critical hallucination here, is the modification of the face. How we solve it? As I said before, the first step is to get a predicted binary mask. We applied a dilation to this binary mask, and we ran an in-painting process. And then we added a step to get the segmented face mask, and also a bounding box that frames the complete head of the people that appears in the photograph. Then we paste the pixels corresponding to the face of the person and to the fully restored image. And we got a better result, preserving the identity. There was another inconsistencies in the restoration, in this case of faces that have stains. For example, in this case, the face morphology has changed, the eyes or the lips has changed, but the another parts of the image has been restored coherently. How we solve it? As I said before, we got the predicted binary mask, we got also the segmented face mask, and also a bounding box that frames the complete head. And in this case, the pixels corresponding to the face of the person were excluded from the binary mask, the original binary mask, and we applied the known dilation. And we ran the process of inpainting without touching the face. And then we tried a new strategy. Run a process of inpainting with the cropped head, the bounding box, and its damage that we extracted from the original binary mask, and we got a result like this one. It's a better result than the previous one. And finally, we overlaid this enhanced face onto the fully restored image. We got a better result than the previous one. Our future work. We plan to conduct a human evaluation over a set of 100 images. We want to compare restorations made with a segmentation with UNID and also the images that were restored by the YOLO plus SAM segmentation function. The people will rate each restoration based on identity conservation, disappearance of stains, coherent reconstruction, and which version they think is better overall. And then we will compare this human evaluation with some metrics that we are researching now that evaluates damage proportion and reconstruction coherence. We also have developed a web application. Initially it was made for testing purposes, and it was used by Bellas Artes users to generate the restoration of the photographs. And it allows us to see the step-by-step of the process of our pipeline. As you can see, its segmentation is made by YOLO plus SAM, and then the restoration is made by stable diffusion in painting, getting results like this one. Now we are evaluating to enable this tool for public use. And we would like to give a special thanks to Professor Pedro Vicente and his team that is working every day in the task of cleaning and preserving the photographs and the digitalization of the photographs. Roberto Paredes that gave us some suggestions or recommendations to enhance our detection and segmentation algorithms. We would like to acknowledge also Consellería de Innovación, Industria, Comercio y Turismo for founding the chair of artificial intelligence applied to public administration. Also BRAIN because they provided us a technological infrastructure to execute our algorithms. Samsung for provide the equipment to conserve the cleaned photographs. Fujifilm because they will provide a photographic paper for printing the restored results. And also World Central Kitchen for generous economic donation for the project. And I want to finish with a final thought. Artificial intelligence is not here to steal something from us. It is here to help us recover our memories. And that's all. Thank you.
Any question?
Okay, very good work. I have two questions. First, have you considered to use flags models that have already in painting? This is one thing. And the other thing that now that you have already some well-restored images, why not to use these as a way to fine-tune either stable diffusion or flags to improve the accuracy in the process?
Okay, the first one, we tried with a stable diffusion 1.5 in painting model, a stable diffusion in painting 2 in painting model. This is a stable diffusion XL 1.1, 1.0, and also we try with flags in painting, but flags consumes more computer resources. And with the limited computer resources that we have, it was hard to try with flags. We got some interesting results, I know, but by the technological limitation, we finished with use stable diffusion. And the second question, do you mean because we? Oh, can you rephrase, please, or repeat that?
We have now a lot of already restored pictures.
Yeah.
So you can use the origin and destination in order to have a good data set to fine-tune the model and to increase the effectiveness and to reduce also these artifacts and hallucinations.
Yeah, it's a good observation. It's an item that we are planning to try because these are photographs that of the real life, and we can, for example, in the YOLO plus SUN2 approach, it was very easy to train YOLO because labeled with bounding boxes is easier also than label segmented mask with unit. For this reason, with a few examples, we can get better results. But it is a good observation because when we have already more amount of restored photographs, we can try in fine-tune, for example, a stable diffusion model to only with this model get already a better result. Yeah.
Okay. Do you have any question? Nobody? Thank you.
Thank you.
Well, thank you very much. Now we have finished the event, the full ValgrAI Scientific Council Forum event. Thank you all of you for your attendance and your support. And now we have time outside for networking, eating something together, and discuss about all these interesting presentations. Thank you very much.